Good afternoon, sir. We are the CMG4 and we're going to present to you our proposal entitled Investigation of First Flush Phenomenon, a water quality analysis on collected roof runoff in Bataan Peninsula State University main campus. For our introduction, there are 785 million people have no access to basic water supply. This is because climate change has an impact in our water cycle. As you can see in the figure below, as the temperature of our surrounding increases, the potential of water evaporation also increases. As a result, water scarcity is observed. In order to address such problem, rainwater harvesting is implemented. It is a process of collecting and storing rainwater for non-potable purposes. The advantage of rainwater harvesting system are can ease water crisis, lessen the pressure on traditional water sources, reduce non-point source pollution load, control waterlogging issues, avoid floods, aid in climate change mitigation, contribute to stormwater management. The challenge for rainwater harvesting is the first flush phenomenon. The term first flush or foul flush refers to the contaminated volume of water that flows from a roof at the start of a rainstorm. The first flush diverter is necessary for rainwater treatment. Thus, knowing water quality is necessary for us to identify the usage of rainwater and to know the level of treatment that is needed to be performed. The study will be conducted in Bataan Peninsula State University main campus located in Balanga Compound, Balanga City, Bataan.
As for the statement of the problem, the study focused on solving the lack of water quality data in PPSU main campus for implementation of rainwater harvesting and treatment. In order to address this problem, the study is sought to answer the following questions. What factors are present in the study area affecting the quality of collected first flush? What are significant effects of rainfall intensity and duration on the quality and collected roof runoff? And how much water should be diverted to collect a less contaminated roof runoff?
As the general objectives, the study focuses. As a general objectives, the study focuses to assess the first flush phenomenon and its parameters affecting the quality of collected roof runoff in Bataan Peninsula State University main campus. The specific objectives are: first, install the collection points for gathering in situ data for rainfall intensity. Second, to measure the physicochemical parameters and nutrients. Third, to estimate the volume of first flush for non-potable rainwater harvesting.
As for the significance of this study, by assessing the water quality of collected roof runoff in PPSUMC, the study can provide recommendation for implementation of rainwater harvesting and treatment, which could help in designing proper rainwater collection system. And the study also aims to promote the use of rainwater harvesting, which could help in reducing stormwater runoff in the community. Furthermore, this study is extremely beneficial to water management and projects of BPSMC, which may help in formulating policies and methods for reducing water consumptions.
The study of Lee et al. 2012, it found that galvanized steel roof are the best suitable material for rainwater harvesting application because it meets the physical, chemical, and biological water quality metrics of Korean and World Health Organization drinking water quality criteria. Furthermore, in Spearman's correlation coefficient test performed by Wyoming C et al. 2020, it discovered that steeper slope has recorded lower level of pH. Moreover, in, in some studies said that smooth catchment is highly recommended than rough surfaces. While rainfall intensity and duration according to Mohammed 2016 affects the level of pollutants concentration. In simulation of Schiff et al. 2016, during simulated storm events of same duration, the lowest rainfall intensity consequently had the highest pollutant concentration, while the lower rainfall duration, the lower the pollutant concentration. Debris like bird droppings, leaf, dust, and etc., as stated by ZAB 2020, are mercurial pathogens that causes the most contamination. As per conclusion, Several studies prove that roofing, rainfall intensity and duration, antecedent dry days, and debris accumulated on the roof have significant effect on the water quality collected rainwater. Figure shows the gizmo or battle area. Battle area used to understand how quality changes as storm progresses. The basic concept of battle area is that first battle assumed to fills with most contaminated rainwater. When the water bypasses it, it continues into the second battle in the series and so on. Different results gathered from various related studies which indicates that the first flush phenomenon is site specific. Despite the fact that several studies have been conducted in various countries to assess the quality of collected rainwater, Philippines specifically in Bataan has limited data on assessing the parameters affecting the quality of collected rainwater.
As for the theoretical framework, the first flash concept is originated in the stormwater and sewer literature, but has also applied in roof rainwater harvesting. However, Martinson and Thomas 2005 highlights the underlying differences between rainwater harvesting and urban landscapes. Additionally, assessing the first flash volume is critical. As mentioned earlier, the first flash phenomenon is site-specific, meaning the volume that needs to be diverted is depends on the factors present in the area. Factors like roof material, quality, location, rainfall intensity and duration, antecedent dry days, atmospheric pollution, and contaminants. With that being said, prior related studies propose and recommend the volumes of first flash based on different parameters. According to Yaes et al. 1989, a volume of 0.33 millimeter is needed to be diverted in order to avoid microbial contamination. Tail et al. 2003 proposed a 0.83 millimeter or first 10 minutes of rain to be diverted but should be decreased during rainy season. Martinson and Thomas 2005, which studied the relationship of turbidity, rainfall duration, and water quality, proposed that for each millimeter flash away, the contaminant load will be halved. As for an average size roof, Cunliffe proposed a 20 to 25 liters of rain to be diverted. And lastly, Texas Water Development Board 2005 seen the significant effect of dry days, debris, and season on the quality of collected rainwater. Thus, it come up with a volume of 0.41 to 0.82 millimeter to be diverted. This data helps or will be used in order to validate the estimated volume of first flush for rainwater harvesting in Bataan Peninsula State University main campus. But it still depends on the level of pollutant concentration, rainfall duration, and volume of runoff.
Due to the lack of water quality data, the first flush treatment in rainwater harvesting of the Bataan Peninsula State University main campus is not addressed. Thus, the study aims to close the data gap and identify the different parameters affecting the quality of collected runoff. To identify the occurrence of the first flush, examining the quality collected runoff is needed to determine the factors affecting it, such as physical, chemical, and microbiological parameters present in the roof, and the atmosphere where rain pours down. Rainfall intensity and duration will analyze to determine its correlation to the quality and quantity of the first flush. The study will consider the effect of roof area, slope, and roughness. As expected, the study will provide an estimated volume of the first flush and an overall assessment of the quality and collected runoff to generate the sustainable report for the implementation and treatment for the rainwater harvesting in DPS-UMC. The various methodology will use to collect and analyze data for the study. The methodology used in the study is combination of descriptive, analytical, experimental, and historical methods. Present here is the flowchart of methodology wherein the four major components are the preliminary data gathering, selection of collection points, first flash analysis, and lastly is the result validation.
For the first phase of methodology, which is the data gathering, the historical and collected data will be used and considered when assessing roof and rainfall events using reliable or available data. However, drone camera will be used to evaluate the roof slope and area. For the second phase, which is the selection of collection points, the installation of appropriate collection points will be utilized to assess the quality of the collected sample and test it for the quality considering various parameters. Figure 4.5 shows the mock design of a rainwater collector or sampler. The sampler consists of a series of horizontal bottles linked together by a long PVC pipe that constricts the mixing zone and prevents subsequent water from mixing with the already filled bottle. However, the rainwater collector is connected in large downspout while the excess water will spill from the spout. For the analysis of the first flush phase, testing procedure will be done to assess the overall quality of harvested rainwater affected by physical, chemical, and microbiological factors. Collection of rainwater samples after the storms or rainfall events will be stored in a sample testing container. Then samples will be tested for psychochemical and nutrient content such as pH, electrical conductivity, total suspended solids, dissolved oxygen, and ammonia in the laboratory. Microbiological parameters suggest to be tested within 24 hours after the collection. Once the results are obtained from the laboratory, results will be analyzed and validated. And for the last phase of our methodology is the validation of results. The validation of results will be based on the related journals for rainwater harvesting. The estimated volume of first flush will be validated using journals and the proposed quantity of initial flushing to improve the quality of harvested water. The study will seek to collect and analyze data on the relationship between water quality, water quantity, and rainfall duration.
The timeline of research will be started on March to July 2022. The primary data gathering is March to April. Selection of collection points is April to May. And April to June is the first flush analysis. And June-July is the result validation. And these are the references. Thank you.